Imagine the value of having the ability to change your business logic, parameters and filter conditions without downtime or restarting of a Flink application. Sounds awesome, right? Welcome to the part 4 of the video series in which we are building a real-time gaming leaderboard application using Apache Flink. Over the course of 5 episodes, you will learn all parts of streaming architecture starting from ingestion, enrichment, all the way to the visualization. You will also learn advanced analytics techniques like control channel for A/B testing, handling late arrival of data, exactly once, archival and on-demand replay of data. In last video, we completed processing, storing results and visualizing on our leaderboard on Grafana. If you are new here, please watch the first video, I highly recommend it. In this video, I am going to explain the control channel method using which you can apply parameter changes immediately to the application without restart or downtime. What are we going to add in this video then? For the control channel technique, we will have another Kinesis data stream responsible just for holding the configuration. Imagine you have to execute a query with select star from table A where column A has a value of 50. And this value 50 is kind of the dynamic in nature and you want to externalize it somewhere. Imagine you have similar events coming from config channel which gives you the value and updates of this value from configuration. So, first one, let us say at time t1 you get the column 1 value at 100 and after some time in future, maybe after a week or a month or a year, whenever your business logic changes, you want to update this externalized parameter value from 100 to let us say 300. Well, what you need to change in this case in your Flink SQL query is replace this value 50 with the select query like this. And as you can see, this select query basically selects the latest value from this configuration table and uses that in the filter condition. What advantage it gives us is whenever you have a new configuration coming from the config channel or the configuration stream, that gets immediately applied in the application without the need of a restart. So, what are the applications of the configuration or control channel technique? First, it is A/B testing or shadow testing. Second, feature switching where you can dynamically change the code branches depending on the business logic. Third is parameter update, just like the example we have seen to apply it in where clause. And finally, for adapting algorithm, you can imagine ML driven algorithm which can update the parameter or even the application can update itself by pushing the parameter continuously. So, let us understand what the code looks like for the config channel. As you see, I am already in the branch 4. If you are not, you go to the GitHub, select the branch 4 dynamic config setup, take a checkout and you will see the code like this. So, what has been added in part 4? First one, a new stream called config which is essentially a Kinesis data stream, and second is the data generator which is basically a Lambda function responsible for publishing an event. What you can do with this Lambda function? It is pass through function. So, whatever you give as the input, it just passes to the Kinesis data stream. Now, let us go ahead and deploy this. So, I am already in the infra folder. I will say cdk deploy, hit enter and wait for it to deploy. When prompted for the changes, I will say yes. Again, if you have any questions, please leave in the comments and I am going to answer them. We have already talked about our approach to utilizing the config channel. Now, let us engage in a practical exercise to deploy a new stream and apply control channel logic in our notebook. Once you see the CDK stack is deployed, you can go to the Managed Flink service and open the notebook. What you need to add now is a new table called config, and as usual it is a standard table referencing Kinesis data stream. You change the region and then you can use this query to select the top one record, order by time descending to see the changes as you push the event from the Lambda function, which I will show you in a bit. Purpose here is to filter out the boards. So, let us see what the is board column looks like in the player table. It is basically an integer with two values, either 0 or 1. So, 1 means it is a bot, 0 means it is a real player. So, the idea is to keep only the players and filter out all the bots out of the game. So, let us go back to the config table. In this case, you can use the new version, which is leaderboard V2, which is essentially exactly same as leaderboard V1, and register that as a view as well. Here we will be using shadow testing or A/B testing concept, which means that without disturbing leaderboard, we will create a new leaderboard called leaderboard V2, just to test the new version of the application in parallel without disturbing the old one. You can refer these links to learn more about the different operation and write a query as I explained in the previous slide about filtering the bots. Now, let me show you how you can push the config event from the Lambda. So, you go to the cloud formation, in the output tab, you will see the new URL config publish lambda URL. You hit that URL, which takes you to the Lambda console and opens the Lambda function. That is the one which pushes the event to the Kinesis data stream. You copy the example event. Basically, you specify the stream where you want to push the event and the data. In our case, we want to filter is bot 0. That is what is reflecting. Let us copy this event. Go to the test tab. Here, I will quickly replace the JSON. You can give this event any name and save this event for future. In my case, I am not saving it, and I will click test, which will push this record to the config stream. You can see that by the success, and also you will see the shard ID and other things printed, which confirms that the data is pushed. Just one thing to bear in mind, that this method is used when the application is up and running. So, first thing you need to ensure is you run the query, it is up and running, you have the Flink dashboard visible and the data is flowing, the application is stable with no more records coming in, and that is the time when you push the config from the publisher to trigger the change and apply this new config and get the data moving. In this video, we learned how to use the control channel method not just to update the parameters and configuration of our real-time application, but also to use it for shadow testing, feature switching, dynamic filters, or even ML driven application tuning. In next and final video, I will explain you how you can tackle rest of the common streaming analytics challenges such as late data arrival, avoiding data duplication, archiving, and on-demand replay. See you there.